So we'll continue, and we have our survey results. So this is the table with the survey results where, for example, 29 males said that they chose Spanish. So this is what we found in the survey. Now we're going to set up another table of expected values. So these are the values that we would expect from the total numbers of males and females and French and Spanish and Russian students that we have, and see what these probable values would be. So we can set up the table in the same way, but this is not going to be the survey results, but a table of expected values. So what is the difference between these observations in the survey and expected values? You might remember that the expected value E can be written as the number that you have in the sample multiplied with the probability. And we can also label the data differently, that we make sure that we know that these are observations, whereas what we'll get down here is going to be expectations. And expectations build on a probability that we can calculate rather than observe. We can start off by looking at this probability. Let's say you don't know the details of the survey. You only know the totals here of males and females and French, Spanish, and Russian students. So what would the probability be of a random person picked out here being both male and French student? Oh, my mistake. I've managed to reverse the categories here. It should say female and male and female and male, and that's consistent with the previous video, sorry. So we'll just rectify that here. So what's the probability that a random student is female and a French student? And just to illustrate that, we could go back to the tree diagrams to see how this would work out. Well, out of these 150 students, 50 are female. So first off, in a tree diagram, what's the chance of picking out a female student at random? That would be 50 out of 150, and likewise picking out a male student, the chance of that would be 100 out of 150. Now, if we already know that we're talking about a female student, what's the chance that this student is a French student? And generally, the probability for being a French student is 40 out of 150. For Spanish students, it's 69 out of 150, and for Russian students, it's 41 out of 150. So when we're talking about the probability of being female and French student, we can write this as the intersection, female and French. So remember, we can read this intersection symbol as and. Now, to find that probability, we had to multiply the probabilities like this. And now we have found this probability that we needed for our expected value. So the expected value is going to be the probability, that's 50 times 40 divided by 150 divided by 150, and then multiplied with the number in the sample, which is 150. And what you see here then is that you can cross out two of these. So divided by 150 multiplied by 150, that's going to be 1. And you're left with this expression here, 50 multiplied with 40 divided by 150. Now, if you look carefully on the diagram, to find the expected value for a given cell, if we're looking at this one, we take the total for this column and the total for this row, and we multiply them, and then we divide by this number here. So 50 multiplied with 40 divided by 150, that's approximately 13.3 with 3 significant figures. We can calculate the rest of the expected values in the same fashion. So if we take 69 multiplied with 50 divided by 150, we get 23. If we take 41 times 50 divided by 150, we get 13.7. 40 multiplied with 100 divided by 150, it's going to be 26.7. 69 multiplied with 100 divided by 150, it's going to be 46. And 41 multiplied with 100 divided by 150 is 27.3. So now we have a table of expected values. And this is the basis for comparison in the chi-square test. So the farther away the observed values, the observations are from the expectations, the greater the difference, the greater the chance is that there is some sort of dependence here. Now, an important last point. For this data set to be valid for a chi-square test, you want to check that all your expected values are greater than 5. So all of these values in the cells have to be greater than 5. If not, you can't really do a chi-square test in a valid way. So it doesn't matter with the observations. They can be smaller than 5. But if any of the expected values are less than 5, you can't do the chi-square test.